Alrighty, dogs, we are going to continue our discussion on passive transport. We're going to start with simple diffusion. So simple diffusion is when substances move from a high concentration to a low concentration until dynamic equilibrium. So dynamic equilibrium, it's a constantly changing kind of balance there. So obviously you're never going to be precisely at that exact happy medium, but the goal is to fluctuate really around that equilibrium point. And simple diffusion, substances move from a high concentration to low concentration. There's no ATP required, so it doesn't require any energy for passive transport, especially simple diffusion here. And it usually is to transport smaller substances across the cell membrane. So nonpolar substances, since they don't require a carrier or a gate, they just pass right through the cell membrane. So when there's a higher concentration on the outside of the cell membrane compared to the inside concentration of a particular substance, substance is going to move into the cell until that dynamic equilibrium is reached. So you could think of let's say water pouring out of a cloud. Whenever it's about to rain, you got the water in the cloud. So there's a high concentration of water in the cloud, low concentration obviously of water outside the cloud. So once that high concentration gets built up so much, the water moves from a high concentration to a low concentration. And rain on my head, call that brainstorming. But from that high concentration, I hope you got that little Wayne lyric, by the way. If you did, thank you. But high concentration in the cloud, low concentration, the water moves out of that cloud from a high concentration to a lower concentration of water on the ground. So that's simple diffusion. High concentration to low concentration until dynamic equilibrium is reached. Usually transports nonpolar substances, smaller substances, and no ATP is required. But factors that do affect simple diffusion are temperature. So you increase the temperature, increase the rate of simple diffusion. Vice versa, decrease temp, decrease rate of simple diffusion. Increase the steepness of a concentration gradient, increase the rate of simple diffusion. Vice versa with that as well. Also, the thickness of the membrane plays a factor. So you increase the thickness of the membrane, you actually decrease the rate of the simple diffusion, and vice versa. Decrease the thickness of a cell membrane, you increase the rate of simple diffusion. So thicker membrane, lower rate of simple diffusion. Thinner membrane, greater rate of simple diffusion. So simple diffusion increases the rate does when there's a thinner membrane. And also mass is a factor, so you increase the mass of substances, you decrease the rate of simple diffusion, and vice versa. Decrease the mass of substances, you increase the rate of simple diffusion. So analogies for these, for the temperature, let's say, the hotter the coffee is, usually the easier sugar mixes up in it. If you have cold coffee, cold brew, it takes a little bit longer to really mix up. But hot coffee, increase the temperature, increase the rate of that simple diffusion going on in there. Obviously, the concentration gradient, the steeper the gradient, the increased rate of the simple diffusion. So think of a steep slide. The steeper the slide is, you get to the bottom quicker. If you make the slide a little bit longer, it's still fun, but maybe the kiddie slide, we'll call it. So the kiddie slide takes a lot longer to get to the ground. The big grown man slide, we'll call it, boom, going straight to the bottom there. So think if you're at Sandcastle, around the water slides, or any water park, wherever you live at, steeper slide, get to the bottom quicker. More gradual the slide, takes longer to get to the bottom. Same thing with simple diffusion. Now, discussing the thickness of the membrane. So you, let's say, increase the layers of clothing you're wearing, you won't be able to move as quickly. So if you have about 10 layers of a thermal, a hoodie, a jacket, you can't move as quickly. Obviously, if you take those layers off, you can move more quickly. So thicker membrane, decrease the rate of simple diffusion. Thinner membrane, increase the rate of simple diffusion. And mass, increase the mass, decrease the rate of simple diffusion. An analogy for that is, let's say a group of sumo wrestlers can't run 100 yards as fast as a group of triathletes. So there's more weight. It decreases the rate of simple diffusion. So a bunch of sumo wrestlers can't run as fast as a bunch of triathletes. So increase the mass, decrease the rate of simple diffusion, decrease the mass, increase the rate of simple diffusion. And that's simple diffusion.